move to a different type of loading. Previous part of this lecture only dealt with completely reversed load. And this second part, we estimate failure when load is not completely, when stress is not completely reversed. The previous method, the SN diagram, is applicable for completely reversed stresses. Completely reversed is when we have stress that is changing from maximum positive value to a maximum negative value. So one point in the material goes through positive stress in one direction and negative stress in the other direction, uh, like a bending, uh, pure bending conditions. Okay. Uh, Now load sometimes is not completely reversed, and stress is not completely reversed. What happens if you have, let's say, if the machine element or machine part is subject to repeated load? That will lead to repeated stress. So let's say that you apply 150 Newton at one specific point, and then you just remove that load completely, and then you're putting that load again and you're removing it again. So what you're doing is you having a repeated stress to a maximum value and then zero value, maximum value and then zero value, and so on. So that is a repeated load. Repeated load, repeated stress is not completely reversed. Same with general fluctuation. General fluctuation stress is a stress that fluctuates between maximum value and minimum value. So let's say that you have a combination of shear stress and bending stress. The result will be maximum stress of a value. Let's say stress will fluctuate between a maximum of 250 and minimum of 100, 250, 100. So the element is always under stress, but that stress changes between or fluctuates between two values, and this is not completely reversed. So if load is not completely reversed, we cannot use SN diagram. In that case, we can divide load into, or stress into, two components. We say we have mid-range component and we have the alternating component. If this is the fluctuating stress, we will have maximum here, sigma maximum, and minimum value here, sigma minimum. The average value between maximum and minimum is this one, mid-range stress, between here and here. So this is the mid-range stress, average between maximum and minimum. And then the other component is the alternating. So the amount of alternation, sigma A, is how much you increase and decrease from that mid-range stress. And this is called alternating stress. So it is an absolute value, it's always positive, absolute value, sigma maximum minus sigma minimum by 2. Now we have two stresses.